जय जगन्नाथ जय माँ समले दयाबंती करुणामय ईश्वर एक सुंदर समय आमको उपहार देइछन्ति। I would like to welcome you the 4th day of FDP of training program. Today we have a dynamic personality with us. He is working as a professor in civil engineering department of NIT Raulkela. He has 30 years of teaching and 25 years of research experiences in the field of river hydrology, computational hydrodynamic, computational hydrology, and fluid mechanics. Apart from many administrative academic research activity, he was the Dean AIR of NIT Raulkela from July 2021 to 2023. He has published more than 100 literature international journal and more than 200 paper review international conference paper. He has research collaboration with INRA, Lyon, University of South, USA, UK, many more. University of UK, University of Leeds, lots of things. He has also research collaboration with reputed IITs and NIT. Give a huge round of applause for Professor Kishanjit Khatua Sir, Department of Civil Engineering, NIT Raulkela. Sir, I would like to welcome you on the dais.
Good morning to all of you. My voice is audible to all of you. Thank you, Ms. Priti, for the introduction. Really, I feel very much happy to be here again, my alma mater. And many times, actually, it's our water resources research groups and professors who are many times who are interacted and regularly we are in touch. Thanks for the invitation, actually, Professor Kaur and Professor Kirti and other professors from VSSUT. And I feel very happy to be here to deliver the presentation topic, understanding the typical aspects of river morphology and its implication. Here, actually, I will discuss regarding what is our river morphology and different variables are playing role and its impacts, other things. Then we'll discuss some of the research works that we have already done in our hydrology laboratory at NIT Raulkela regarding the consequence of this river morphology, means converging channel, converging, diverging, and regarding the sedimented bed channels. Okay, so let us start with this river morphology. pointing. काम करनी है ना? Okay. Ready, sorry. Read, है ना? अच्छा, तो देखा हमने. Okay, understand. Okay, thank you. So, you see, everybody knows how river is important for us, and simultaneously how much it is complex for analysis, very much complex, though it is simple and very much important for anybody's our lives. But to understand actually the things, it is complex. And in that actually many studies are there, and one of the topic is river morphology. And the river morphology, it refers to the study of physical characteristics of features of the river, including shape, size, and how they change over time. Means two things you'll see: how the river is changing and with respect to time. Okay, rivers geometry is changing, and with respect to time, how everything is changing, and that change is due to, you can tell, two things: one is space, another is time. Understanding river morphology, again, it is very important, mainly related to ecosystem and management. See, generally we tell the channels, and channels are, again, we can have creeks, brooks, tributaries, and rivers. These are the English terms. So all these things we can apply, we can tell as channels. Sometimes you can channel morphology, river morphology. River is a particular, when it is size is large. Okay, and I told that the study of channel due to geography aspects and fluid dynamic aspect. Actually, these are the slides actually I have collected from internet after the invitation from Professor Kara, and actually I immediately collected some figures, good figures to explain actually. And you see here how this the river has three courses. You see, generally upper course, middle course, and lower course. And during the flow, how the shapes, sizes, and platforms, and materials, geometry, everything changes. You see, that study is we can have in two ways: geography and another fluid dynamic aspect. So in the geography aspects, it is changes of river platform and cross section, seven size already I told, and another is quantity of flow, that is a fluid dynamic aspect, and sedimentation, erosion, and transportation of that sediment, these processes. So again, see, same thing actually I have written here, A and B, and A is already told, and B is this morphodynamics. And morphodynamic processes mainly you see erosion, transportation, and deposition actually, and generally we call this as fluvial hydraulics. This study that morphodynamics processes that we study, that is our fluvial hydraulic. So what is fluvial processes? You see, because we see here many slides are there, and my time will be maybe I think 1.5 hours. That's why I have to go very quickly because there is more than 100 slides. So contents are there very okay. So anywhere if you feel anything to discuss, we can discuss. So I have to go quickly. Fluvial processes carries three things: erosion, sediment transport, and deposit. जो अपर से आता है ना, Okay, that eroded. Erosion process it is goes on actually, but at the upper course, due to high potential energy, the erosion process is very high, and then sediment transport. Then finally, deposition actually occurs mostly in our coastal regions at the downstream part of the before joining the sea. And you see, what are the factors that determine the degree of morphological development? I have summarized here 6 factors. This is very important actually, because if you know this, you can apply for research works or for any our design works and for any project works. Flow strength. First is we have to see in a river the flow strength. It is slope. Because slope, you know, that is actually helping to invest the potential energy. In a river, due to slope, actually, that is rho gas, weight component. Okay. First factor we can tell. Then second, we tell flow in the flow strength, discharge, width, and velocity. All these are we call as flow strength. Then sediment supply, sediment composition. Sediment supply तो होता है, again composition is also important. Your gravels, cables, okay, sands, all these things actually you have to see. Then the bank erodibility, vegetation, these things we'll discuss one by one. Then frequency of flood also very important. All these factors combinedly decides the river morphology. How the river morphology is changing, happening in the course of time. These 6 factors defines. Now I have prepared for you this. What are the variables actually? In terms of variables, plays the role in river morphological development. Variables generally we call it 2 types: dependent variable and independent variable. Independent variables, landscape variables are geology, climate, and human. Okay, these things actually I don't want to spend more time here, very common things. And these 3 are we call as independent. Okay, that is from nature and directly we are getting actually that are called independent variables. And dependent, we actually depend, that is frequency, volume, and your quality of the sediments. First category. Second is frequency, volume, and duration of the stream flow. Third is vegetations. Okay, these are dependable variables. And dependent channel variable is actually, again, this is dependent channel variable depending upon all these 3 dependent landscape variables. The channel dependent variables are width, depth, bed slope, grain size, bed forms, sinuosity, scour depths. All these things actually, these are the dependent variables. What are the human impacts role actually for this morphological development? You see, all of you know that our impact is also there in our morphological changes. Okay. First is pollution, because generally pollution nature से होता है भी, but many times you know artificially by man-made pollutions are being made, and we are disposing all those things to the river, isn't it? And due to that actually you see your density of that and your sediment properties are changing. That also has a role actually for changes in morphological nature of the river. Then Again, second thing is altered hydrology. Due to human, we construct dams, bridges, many hydraulic structures that also have an impact in the morphological development. Then habitat destructions. That cities and the development, human settlements occurs in the near to the rivers generally. Not only now actually, in the history actually the human civilization has occurred near the rivers, and due to that actually we are sometimes destroying this habitat, and that also plays a role in our this morphological development. Deforestations, channelizations, land development, all the things actually destroy natural habitats. That you see this vegetations, how it has a role. We know that just to see in that summarizedly, bank stabilization. Vegetation plays a role in bank stabilizations, shading and cooling, and filtering pollutants. All of you know these things, not it? So vegetation का जरूरत है. We should not destroy it actually. Sometimes we destroy, sometimes by nature also it is destroyed. But it has a role actually for this morphological development. Now we'll discuss about the components or part of channel morphology. Okay, I told you how this morphology changes and the definitions. Now we'll see what are the components of the channel morphology. I have already told in two parts, that is the geometry and fluid dynamics. That geometry actually I can tell you. First A is your channel geometry and hydraulic geometry. Actually, that two parts what definition I have told, dividing into three parts as a component. First is channel geometry and hydraulic geometry. And second is actually fluid dynamics, the morphodynamics what I was telling. Channel geometry, channel length, width, that I don't want to spend more time here. All these things. And the hydraulic geometry, channel types and patterns, and the fluid dynamics. In the fluid dynamics, we see the channel discharge capacity. These are the actually components, or we can tell parts of the channel morphology. Sediment load, channel energy, all the things are actually the part of that channel morphology. Finally, the transportation capacity. Okay, so all the things actually very quickly I will show you. This channel geometry, 1, 2, length, width, beds, all the things. Yeah. You see, channel width, channel depth. Today you see the size, width, and depth. Tomorrow means actually it takes more time actually. After some years, you see that everything changing. Okay, that thing. This is called channel geometry. One main thing I will tell you, your sinuosity. Sinuosity term. Most of you must be knowing that meandering channel में sinuosity होता है. What is that? Can anybody tell what is sinuosity? That is telling about the planform geometry of the river or channel. Sinuosity, just very simple language, you can tell the bend lengths by the straight length. During the flow of the river or channel, okay, it does not join in a straight path. It bends. Okay, it makes a sinusoidal curve. You know, again, that theory is again vast theory is there. I know our many of you actually have already done research on that. the Mandarin channels. Okay, so in a sine curve, actually it consumes very less energy as compared to the other paths due to the least resistance. Actually, it goes in a sinusoidal curve. Remember, that's हमारा you see the wave motion, you must be knowing. It is in a sine curve. Why? Also, you see the snakes. Snakes जो path लेता है कैसे ले आता है? Sine. What I understand actually, sine curve generally it has been actually proved have a least energy expending. Okay. Madam Lakshmi Priya, just you know that actually she has done during master regarding this Mandarin channel. Okay. So this is a Mandarin channel, and sinuosity tells actually. Next slide I'll show actually how this your sinuosity tells the definition of different Mandarin channels. Channel types and patterns, channel bed topography. So you know all the things: alluvial channels, bedrock channels. Many definitions are there according to that. Actually, the grain size of this your sediments, bed surfaces, and on the basis of geoclimate, we also define that effluent channel and influent channels. Sinuosity actually it is written here. It is the ratio of stream length to the valley length. You see here. Straight distance, so length of the stream channel by length of straight distance, it is written. So that is sinuosity. Again, this has been extracted actually from the internet. You see, we call straight channel, sinus channel. Generally, a river does not maintain straight, but for certain point of view, actually, when sinuosity is less than 1.05, we assume as it is straight, but generally it is not straight, never be straight. Then when 1.05 से ज़्यादा होता है, sinuosity I told that band length by straight length, we call a sinus channel. जब when the sinuosity is greater than 1.5, it is a meandering channel. And there is again braided channel and Armstrong-Ozing channel. All this actual definition you will get from the standard books. This is a figure of a bedrock channel. Here actually uniqueness is it controls such as joints, bedding planes, and geological strata can also have a significant effect on flow processes. सबका actually that effect is there. Alluvial channels, bedrock channels का सब effect है, and how the effects is there, that we have to see. Then effluent channel and influent channel. You see in the figure. Effluent channel is the channel which is under the water table. Means पानी आता है ground water से आता है, and okay, that is called as effluent channel. And influent channel means water table below जाता है ऊपर में. River. Okay, only during rainy seasons or okay, some specific periods we see that पानी बहुत अच्छा है, उसके बाद पानी खत्म हो जाता है. Okay. Again, channel bed topography. So many terms are there in our laboratory in NIT Rourkela. NIT Rourkela Hydrology Laboratory actually it is one of the best laboratory, not in our country, in the world, I can tell. Because I have collaboration with all UK universities already. University of Birmingham, Nottingham, Loughborough. Okay. Madam knows actually because many of you also know Loughborough and yeah. Because actually this regarding Mandarin channels, UK universities, they are doing a lot of work in Mandarin channel, compound channels. NIT Rourkela in our country also we have been doing through many projects, DST and Eco India projects. Okay, like